Greetings, Physics 2001 students. This is the mini lecture to accompany the final lab of the semester. That is the heats of fusion and also vaporization lab. That's called experiment number 18. So in this lab, what you basically do is you're going to measure the latent heat of fusion and vaporization of water with a pretty neat device. It's unfortunate you don't get to work with in person. You're going to add steam to a cup and then add ice to a cup and use that to measure these heats, or these latent heats. So keep in mind that fusion, what we're talking about, that's a liquid to a solid phase change or a solid to a liquid. That's what the fusion is. Vaporization, we're talking about the liquid to gas or gas to liquid transition. So the key equation here, right, is that the energy lost by a hot object is equal to the energy gained by a cold object or objects. And this is the key equation that we're going to use to solve for the latent heats. When you're talking about how much energy is lost or gained, when an object is changing temperature, you use this equation that when you add some amount of heat or you lose some amount of heat, how do you calculate the temperature change? Well, it's equal to the mass of that object times the specific heat times the change in the temperature. If you have an initially hotter object, your change in temperature is going to be the initially hot temperature of that hot object minus the final equilibrium temperature. If you have an initially cooler object, one that's going to warm up in this process, then delta T is that final equilibrium temperature minus the initial temperature that cold object was at, just to ensure that these are all positive. If a phase change is involved for an object, then there's also going to be some heat involved in the phase change. So for instance, the energy that is sapped by melting some water, for instance, that's this M sub L. This energy doesn't result in a temperature change at all. So for instance, when we have steam, the steam is going to condense to water in part one. The energy lost is going to be equal to this energy due to the temperature change of the steam plus the energy for the phase change when the steam is turning into water. And then the energy gained by the water plus the calorimeter, there's just going to be this MC delta T term in there. So we need to keep in mind that the calorimeter cup is changing temperature too. So both of these things are going to gain heat, and we deal with that in our equations when we're equating Q lost and Q gained. I'm not going to solve the algebra of Q lost and Q gained here, write down the full equation for this particular situation, because it's in the lecture notes, or not the lecture notes, rather, it's in the lab handout. The lecture notes on this topic, in case this doesn't mean anything to you, go to lecture 22 on thermal physics, and that's where you can review this information about how you deal with heat and temperature changes and how you deal with latent heats. So the first part of the lab, step one, is obtaining the latent heat of vaporization. So you are given the mass of the cup, the mass of the water, their specific heats and temperatures. You're also given the final temperature and final mass of the cup plus water. Note that this thing has gained mass because you've added steam to it. So that's how you figure out how much steam was added, right? You subtract the initial mass from the final mass, and that's how you get the steam mass. And then you just need to solve this energy lost is equal to energy gained. And solve that for that latent heat of vaporization, because it's the only variable you don't know in the end. Two is to obtain the latent heat of fusion. So now your initial situation is that hot cup of water that you created in step one. So you heated this thing up, and then now ice is added to it. And that's going to cool the system down. And the temperature is measured once all the ice has melted. So again, you're given the final and initial mass, so you can use that to figure out how much water mass, or how much ice mass rather, was melted, and use that for your ice mass. And then again, you're just solving this energy or heat lost is equal to heat gained, in this case for the latent heat of fusion. And that equation is helpfully provided for you in the lab handout, so you don't need to work it out for yourself. It's just provided there. And that is all there is to it for this lab.